It is recording, so you can start whenever you want.
Okay.
And
I can show the information about the faculty, then I can show this.
okay, that's very good. That's very good.
Do you have any presenter or not? I can just click it here.
Oh, let me see if it's in the backpack. I think it should be here still, unless Mateo he likes to play with it. Maybe it's home. I think it's home.
Okay.
Yeah. He recognizes that thing.
Right. So, shall I start?
Yes. We have people online, so I think
Okay.
it's for them right now.
Okay. So, well, guys, nice to see you. I came from Lithuania, a small country. I will show you later some information about my country. But I also would like to present faculty, what we are doing there. Are you the students of civil engineering? Okay, see.
Yes.
I know these words. Not so much, maybe 10 words in Spanish. Sí, cerveza, baños.
Baños. It's so important.
It's enough to survive. Right, short introduction of my faculty. We have founded the university in 1956, but we started our studies as a civil engineering studies in the other city in 1922, and then sometime we moved to the other city and established the Institute of Civil Engineering, and which becomes the Vilnus Gedminas Technical University. So I'm representing Vilnus Gedminas Technical University. This is the most recent name.
So back in 1922,
that was the studies, civil engineering studies started on our university in our city.
Okay.
Then there was a faculty established in the capital city, and then they become so big, so we made an independent institute.
I see that.
There was a specific institute for civil engineering. We had an institute for different fields, so that was the business in the previous time. The different institutes for chemistry, for civil engineering, for mechanics, things like that. Now we do it in another way. Now we have a big universities with a wide scope. So for the structure, of course, maybe you can see it there. You don't have to care too much about the internal structure, but this is how we do in our country. We have university, then we have faculties. We have 10 faculties in university, and then each faculty have a department, a specific department. So in our case, we have department of building materials, fire safety, department of reinforced concrete structures and geotechnics. This is the one I'm representing myself, so I know something about reinforced concrete. Other fields are not so familiar to me. It's the department of steel and composite structures, department of applied mechanics, and construction management and real estate. So these are. Today we have 5 departments working in slightly different fields. And we have, there are some so-called institutes inside the faculty, Institute of Building Materials, Bridge Structures, and Sustainable Construction. These institutes they don't have students, they have researchers, which, so they are pure researchers. They have research laboratories, and they do the pure science.
Do they work directly with industry?
Yes, if the industry have any projects or any problem to solve, they are addressing the university, the faculty, according to the field of interest, and then we try to lead them to one of the institutes or departments. And also we have one like more or less commercial department, which we call the Applied Laboratory of Buildings, Construction and Materials. So this laboratory have accredited, they have a right to make accredited tests. This is accredited laboratory. So if the industry have some official problems, we want to have a certificate that, let's say, they have some problem with this wall, so we take the samples and they can bring to this laboratory to make the test, and it's official. The number given by this laboratory is official number, can be used in court in case of any problems. So
Is it very profitable? That or is
no.
it just small projects?
No, they had a turnover of €500,000 a year. Not so there are only a few people working in there.
Okay.
But it's not so profitable because they don't have a separate machines. They use the same big machines, which are a little bit too good to them, too precise, too good. So we have kind of problem with it. Some of the external supervisors, which they're telling us that we have to really separate business from science.
Right.
And they want to make more connection between science and the students, because sometimes it's a little bit also separated. The scientists, the pure scientists, tend to make some new topics which are not really related to the departments which takes care about the studies. So that's the problem, and since I'm working in administration of the faculty, that's one of my problems, how to join them and make work together.
That happens sometimes with science. Science gets too far away from the problems we have every day.
Yes, exactly. So that's always changing the system, but generally we have approximately 8 programs, study programs for the bachelor's. This is undergrads, and master degree, more specific. So I don't know what's your time schedule. We have 4 years plus 2 years plus 4 years.
It used to be 5 years in the bachelor's, but right now they are doing a change for 4 years because it's like a common trend worldwide to shorten the program into 4 years.
I can say that we have a problem. There is another trend. In our case, it lasted more than 10 years to have 4 years, and now there is a big push from the industry to make it in 3 years.
Really?
Yes, but then they said,
3 years.
But then they said we agreed to make it in 3 years, but then the bachelors won't have any right to make any certified work. They have to then finish master as a mandatory. So we said that from the point of view of university, it's impossible to make an engineer in 3 years. No way.
That's impossible.
We have to, that's 4 years at least, and this is not a full engineer, but if we're coming to the master. So now it's 6 years, but so we agreed to make it 3.5 and 1.5, or 3 plus 2, or any over, but we need those 5 years.
Yeah, no, it's very complex. We have to do it in 4 years right now. We are kind of moving towards that because the other programs, the electronics, computer science, and the other industrial, they already moved into 4 years.
They can do it easily because they have less theoretical background, then they have more continuous learning things. They can do it. The business management, for example, did it in 3 years. 3 plus 2. They can do it. No, but they can do it as for the social scientists. It is possible if you read many books. For reinforced concrete stuff, structural engineering, no way.
All right, it's interesting.
So for the civil engineering, as I said, we're constantly changing, but this is our core program called civil engineering, very general, with some so-called specialization. So the students, if they have some feeling that they would like to make the structural design or some special structures or geotechnics, they can choose already in the second or third year, and then they have a little bit specific program. For example, if we choose geotechnics, they have
which department professor covers hydraulics? A specific department?
Not in our case. We have another faculty.
Oh.
We have a faculty of environmental engineering.
Oh, I see. Okay.
And they have. So we are very similar to faculties. Sometimes we just become too big in the university, and they split it in 2 pieces.
Okay.
So we are civil engineers with structures, technology, and the materials.
All right, I see.
And the other faculty takes care about the environmental engineering, the heating, ventilation,
waste
management, and things like that. Geodesy also.
Okay. Yeah. Yes.
So we are like artificially split it. Now we become smaller, and I know that our bosses in university have a plan to join us
together, back again.
Yeah.
Okay.
So then it's a life thing. The structure. Some bosses think that by changing the structure you can improve the things. personally don't believe in this. The people can do the change, not the organizational structure.
Yes, in every university, yes.
Yeah. And for the master, by the way, this is that I'm telling. This is pure in English.
Okay.
So you are all welcome. If you know the English language, you can come to us and study.
Very
this.
nice.
So for the structural engineering, our core program, it's full in English from the day one. All the courses.
Even the undergrads?
Yes, undergrads and postgrads and till the doctoral studies.
Wow.
So we are really international.
Yeah, that's.
And we have this full in English undergrad program for more than 15 years now.
Wow.
Because we had the students from Lebanon and the countries like this some time ago. I don't know why.
It's very interesting. I mean, that's one of the main problems we have right now with our programs. We cannot really offer more than a couple of courses fully in English.
Yeah, but in our case, it's very flexible since we offer a full program. So the mobility students or teachers can join almost at any time.
Yes.
You just have to check whether it's spring or autumn semester. I don't know if you don't have spring and autumn here.
No, it's every...
So that's why I'm telling this from 1st of September till Christmas, or from the 1st of February till June. So these are our semesters, so you can join at any time, and they have full in English. That's some social programs we have that join the Belarusian and Russian universities. They are not very popular. We thought that we will get more students, but yeah, not so.
I know the Kaliningrad.
Yes, this is exclave. Okay. So we don't have any border with Russia. We have only with this Kaliningrad state.
Okay.
Okay, so that's for the numbers in the faculty. My faculty of civil engineering is approximately 1,000 students for the bachelor's and 400 for the master's, and we usually have approximately 45 PhDs.
This is big.
For the graduates of that, more or less, the numbers are the numbers are decreasing, unfortunately, but we still have big enough body to have our studies.
Yeah, we had that problem here last couple of years. We have a decrease in students in all degrees.
Yeah, so that's the problem worldwide, I guess. The engineering studies are hard.
Yes.
They are not popular.
Right.
Okay, maybe I can don't stop too much on this. Of course, we have some university priority research fields, so they are covering, we call it sustainable building, and some fundamental research. Other topics are covered by the other bodies. Also, there is so-called smart specialization. Then you want to apply for the funds from the government institutes. We have to say that we are in line of some priorities which are today. So we are setting priorities for the 5 years or for 10 years, and then you can get funds. They are quite wide, like energy efficiency.
It's pretty. I mean, those are the problems we're facing right now. Energy.
Yes. So these two are two which are directly related to our fields of the
What
research.
is the main product of production in the agro-industry field? Lithuania, yes. Professor.
Well, we produce all kind of corn. Also, there is a lot of farming.
Like cattle.
Like yes, cattle, milk, pigs. Okay, I'm not very good in this agroeconomy, but I know that these are the national products. We have potatoes, corn. We have I don't know the English names of all those things.
It's all right. It's very similar to what we have. We have pretty much the same.
Carrots.
We have rice, little piece of rice.
We don't have rice.
Okay.
So this is what we are importing. Okay. So we are a small country, so we are importing most of the things.
Okay.
Okay, there's just continuous list. This is a European program, the big one. It's almost impossible to do it alone, so we have to. This is the reason why we are trying to be so international. If you want to apply for the projects like Horizon 2020, this is the European funding. Again, very general. But you have to find the specific calls for the project, and you have to apply. but these projects are millions of euros, each single project.
Yeah,
You have to be big enough by yourself, or you have to get the partners like, I don't know, like Cambridge University or
some other university,
like that,
yes.
the big ones.
Okay.
Then you can become a partner, so it's not easy to take a lead. Because we are just too small. We have a turnover, I don't know, it's something like 50 million euros in the university. So it's considered as too small number to run the project, which is 10 million euros.
Wow. Okay.
They said that we don't have management capacity enough and experience.
Mm.
So then you have to find the big guy who takes most of the money.
Still is a lot of money. I mean, those projects, they are very interesting.
Yes. And just some pictures from our laboratories. This is, by the way, one of the non-metallic reinforcement. We do a lot of tests, like pulling and so on. This is now our main test beam test setup. Yes.
This is a universal machine.
Yes, this is a universal machine. We can do in any setup. I showed a lot of features. I can show it also today, with the testing of the slabs. This is the slipper test. I showed it 2 days ago, so I will just show it now.
That's for train.
So they are really universal. They can apply the static and dynamic loads. They are fully computer controlled. We have a horizontal actuators, so they can test the structures up to, I think it's 20 meters.
That's a long span.
It's very long span. They can test the real size, real scale specimen.
That over there, is that glass?
Yes, that's the glass, because we have one department for the steel and composite structures.
Okay.
They are working with timber and glass and all the glued things.
Very interesting.
Because the structural glass become very popular as a structural material. So now we sometimes make the facades, and the glass is a structural glass.
Right.
It has a viewing capacity instead of just hanging on the.
That's right.
That's another picture. So we have two big fields, like the playgrounds. One to prepare the specimens. We have a huge formwork with a magnetic formwork sites, or how to call it. So you can, if you as a scientist, you can make a drawing for the slab or beam of whatever sizes, and you can do it. Here is a vibrating table, so you can put the reinforcement, and you can make the real scale big slabs or big beams for the testing. This is, I don't know what's the dimensions. It's something like 8 meters by 4 meters, or the big one. So we have all like industry level laboratory. We have one big, like a factory.
That's right.
Which was exactly built for the laboratory, for the purpose. So that's the slab. So we have a crane, so we can move around all the laboratories. And this is a geotechnical, also the very nice infrastructure. They have a test playground for the foundations. I think it's 8 meters depth, so they can control the water levels. They can control the pressure, different water levels. So they they have a free axial, how do they call it? So they push and they measure all the deformations in the three-dimensional space.
Yes.
So very unique setup because of the size, again, and because of the possibility to control the water level, so they can change the ground.
Yeah, that's unique.
So and again, it's mostly like full-scale, like pile. So you can test the real pile. If you're developing a new type of pile, for the piles, there are new trends to make the pile foundations. And since you don't have the problems with the heating here, but we have it. We consume a lot of energy, so so sometimes we use a geotechnical energy. So there is a new trend of making the piles, which have a structural solution to hold your building. Also, there are the pipes who takes the heat from the ground, because down there in some 10 meters or 20 meters, we have a constant temperature, which is like
it's warmer,
like plus 10 or something. So if you have minus 20 in the outside or minus 10, you can use it by circulating some thermal, I don't know, thermal water, or how do you call it? So we can make those tests here, because if you do something unordinary for your pile, you are not allowed to use it in the industry unless you test it.
Right.
If you put some I don't know, wires in the structural pile to run the water or something like this, you have to prove that it's still safe, it's still good structurally.
That's right. Didn't worry, I'm sorry. I passed a little again on the other. Yeah, it's ready.
Okay, so we actually can work from the macro scale to the very micro scale. We have the electronic microscope, so we can check all the properties of the soil by analyzing the small grains, how do they work together. We also have testing machines. They are drilling the test samples.
That's unique.
There are all kinds of infrastructure is available related with civil engineering, because we had a major investment some time ago, 8 or 7 years ago. We got a big project and the European Union sponsored it. So we invested almost 10 million euros just to buy the new equipment, the best available worldwide. So far we are very good, of course, but we have another problems. We don't have enough running costs. This machinery costs money to maintain. And I don't know what will happen in the next 10 or 20 years, because the maintenance and even for the accreditation, you have to test and prove that they are showing the right numbers. It costs thousands of euros every year. Well, but we hope to manage it. That's another pictures. Some tests of the cables, the supported bridges, and you see this is an external reinforcement, fiber reinforced plates that are attached to the slab. Well, so this is just a picture showing what do we do with our infrastructure. So very shortly, we produce a lot of papers, because even our salary depends on the papers. If you want to get extra,
3 patents per year.
this is mostly national patents.
Okay.
So for the patents, I have a special opinion. Unless the patent is bought by the company, they are worthless.
Right.
You have to just to pay for it. So I don't like it. Mostly nobody bought. We are the member of some international associations. Bridge and structural engineering. This one may be new.
Right. I know CIB.
This is one of the best for the concrete. Yes, so some of our researchers are working directly with this for this creation of new models of calculations. And these are some European institutions which joins all the faculties of civil engineering to share the experience. We have one big international conference. One of them will be held in 2 months. So I'm responsible for this conference. So you are very welcome to come.
I know that would be nice.
Maybe, I don't know. Maybe it's too late now, because it's
right. I think I'm sure everything is
May.
Is it like a yearly based?
No, that's free every 3 years.
Because that would be ready for the next 3 years.
Yeah, so you are very welcome. In the next 3 years, if nothing will change,
that's
we will organize
nice
it again.
Opportunity.
And we have scientific journals, and there are 3 of them who are listed in the Web of Science database. So they are very popular there. Again, I have personal opinion, which is not so popular, that now that scientists write a lot of papers, nobody reads them.
That's a problem. Yes, it happens.
That's a problem.
Yes.
Okay, so thanks for this presentation on the faculty, and I can show some
sure,
presentation.
Professor. The room is yours. You can do as much as you want.
So just tell me when I have to stop.
No. We have 10 minutes still, Professor. No worries. Well, I'm impressed by the 3-year span they are trying to do on the undergrad level courses and level programs.
No, we try to resist. We're trying to resist it. I don't know if we will succeed.
Okay, let me do the this is new. You show me how to do this. Okay, that's
Okay.
new. I didn't know it. Maybe it's duplicate.
Excuse me, I have
Yeah.
a question.
Yes, of course, you can stop me at any time and ask the question.
In
Yes.
Lithuania, what is the portion of the faculty inside of the sea?
What do you mean the faculty?
Inside from the sea is this faculty or outside?
In Lithuania?
Inside.
What do you mean, what city or what? Didn't get your question. Yeah, the
How
faculty.
many faculties in different cities of Lithuania?
Usually compare the universities. We have several universities in Lithuania, and there are only two universities who have civil engineering or similar faculty. We consider ourselves as the best in the country. I don't know, maybe the other guys think in the other way, but according to the international rankings, we are the best in the country, at least. But yes, there is more than one faculty. We have more faculties in the university, and there is more similar universities in Lithuania, but not too much. We have 14 universities totally in Lithuania, but we are a very small country. 14 universities. Yeah, and the faculties who are working with civil engineering, I know there's two, which is directly civil engineering, like mine, and one in our competing university, Linas Technical University, and there is another one which is very small. So the highest concentration of civil engineers is in Vilnius, capital city. Okay, just some short. Okay, I'll skip this contact information. I just can show you a few things about Lithuania.
Oh, this is next. Yes.
Probably you don't know it. This is the country in Northern Europe, close to the Baltic Sea. This is a small sea in the north, surrounded by Denmark, Sweden, Poland, Latvia, the countries like this. I will show you. Oops, this is the map. You know, as you can see, this is the small green piece of land called Lithuania. This is the Europe. So you probably know Spain, since you speak
The
Spanish.
one to the south is Poland.
Yes, so this is the Portugal, Spain, France, Germany, Poland, also the big one, and we are bordering with Poland. For the north, this is Latvia, Estonia, Finland, Sweden, Denmark, Denmark, UK here.
Which one is the one between Poland and Lithuania?
This one, this is Kaliningrad.
Oh, there you
This
go.
is
That's
part
it.
of this is the Russia.
There you go.
And this small piece is which is outside the Russia.
Okay. That's very interesting.
So for the history, since we don't have many time, I can just say very shortly. We are quite ancient country. Lived as a tribes, as a pagans in the north, far away from the Christians, and then we get Christian by force, like you. And in more or less the same time, 14th century, we were Christian by Germans mostly, and we were a very big country. Some time ago, this big piece, that was Lithuanian Grand Duchy. Long time ago, that was the biggest country in Europe. But now,
What time in which year was that?
that was in 14th century.
Okay, I see.
Long time ago.
Yeah.
Long time ago. Then we made a Lithuanian-Polish Commonwealth. I will show this one that was joined Poland, the big country. Also, there was some Ukraine, Belarus, some smaller countries. We bordered it with Russia, with Austria, and with Turks. So we mainly fight it with Turks and with Swedes. The Swedes Vikings approached us, the Russian and the Turks. So we tried to fight, but we considered it as one of the most important countries at that time to stop the Turks, the Muslims, to enter Europe.
Yeah.
So we were at the border. But then you're not so happy to be at the border. You have to fight all the time. So the Lithuanians fight all the time. No peace at all, unfortunately. And we were occupied by Russia, by Soviet Union, not Russia, but Soviet Union and then only in the 1918 they declared the independence. But unfortunately, during World War II, we were occupied by Nazis, Germany, by Russia again, by Nazis, by Germany. So because we are in the middle, unfortunately. So then we were occupied for 50 years, and on 11th of March 1990, we regained the independence. So luckily, since then, we are again independent country. We are very small, but we are independent with our own culture, our own language, and stuff like that. So now we are the members of European Union, the full members of NATO. So we are very happy about this one. Yes. So they are protecting us from the Russia.
Yes, they power.
Yes, and okay. And, so our economy is growing very fast now. So we are not as rich as the Germany or France, but well, we are something maybe half as rich. So we are moving towards the first world, let's say. Okay, that's not important. President, Prime Minister, and Parliament, the usual system. At least in Europe, we don't have king. We had king many years ago, 800 years ago, but now we don't have any king. So we are just a republic like Colombia.
The only two countries in Europe with kingdom is the UK and the Netherlands, maybe Spain.
No. Spain and Denmark and Sweden, lots of them.
Yes,
but
Sweden.
But they have kingdoms which are they are more representative, but not very.
They're not political.
Not political power. So we are just less than 3 millions, with the same density of population like in Colombia. The language is Lithuanian. Okay, and there is 8-hour difference between Colombia and Lithuania. We have 8 hours.
Professor, to be a very small country, the GDP is gigantic compared to what we have in Latin America.
Yeah.
My God, I mean that's...
But then we became the members of European Union. We have a very big support from funds. Before that, the numbers were very different.
The only country in Latin America that can try to do something like that is Brazil. But that's because of the petroleum and all the resources they have.
So we don't have any resources,
That's
unfortunately.
So
our resource is the brain.
Yes, yes.
Okay, and we are mostly Lithuanians, as I saw before. There's nothing interesting. There are still a lot of Poles close to Poland. There are some Russians remain because during the occupations there was some moved families. So they still live there. Okay, I can skip this part. So I already showed the pictures about the university, so I can skip it. We have approximately 18,000 alumni and 10,000 students, and approximately 1,000 of the academic staff, and a lot of partners. So this is we are very proud that we have many partners. Some of them are just friends, and some of them are really active for all kinds of cooperation, the business projects,
that's the
mobility,
type of partnership you want to do.
Yeah, and I already told for the other audience, we are in top 100 in the world for the civil engineering field. So this is the...
Yeah, Javeriana is only top 500. Only top 500. These guys are 100.
So for the generally for the University of Vilnus Gedminas Technical University, we are within top 500.
Okay.
But for these specific fields, especially civil engineering, we are within...
that makes me wonder. Let me see where we are in that standard, Professor.
Okay, it's called Engineering, Civil and Structural in QS World University ranking. And architecture, business management, and economics are also doing well. So I will show you just a few pictures. We don't have many time left.
It's all right. It's all right.
So because that would be only pictures, not so much text, I can skip the text. What we are working on in my department, not the whole university, not the whole faculties, but the department of reinforced concrete structures. The most recent research is related to the flexural carrying capacity and all kinds of research for the void bubble decks or void slabs. I will show the pictures, that would be more clear. We have some big projects with reinforced concrete sleepers, the ones which holds the railway, supports the railway. We have many investigations on the non-metallic basalt reinforcement and the other kinds, actually. I will show you just the pictures related to basalt. And all possible kinds of strengthening of structures. We have a lot of infrastructure which have poor maintenance, so it needs to be strengthened or replaced. So as a scientist, we have to make an investigation and tell for the government or for the company, is it cheaper to demolish and build a new one, or can we repair it? And sometimes because of the heritage, we can't demolish. You have to repair it. So you have to find the way how to do it. And there's a lot of theoretical research ongoing on there are the guys who are creating the very sophisticated models for the calculations of the behavior of reinforced concrete. So for the bubble decks, I can skip this part just to go to the pictures. You see, this is the kind of, we have bubbles made from plastic waste. So they are solving two problems, more than two problems at once for sustainability. First, we use the plastic waste. Then we form the bubbles, which reduce the total volume of the concrete used for the slab by almost 40%. And then then the self weight is decreased. So you also can decrease the dimensions of other structures like columns, foundations. These are one of the recent investigations we did in the department. There is one company involved who tried to enter in the market with these kind of slabs. So this is load-bearing slabs, normal slabs like we have here and here. So we just have to make an investigation if they are good enough to be the structural members. You see there's a different setups were tested, and what problem we had, what about the punching shear? We had a column and the slab which tries to be punched. And we are particularly interested about this area. Can we make it all full of bubbles, or should we make like a cross of the solid concrete, or should we make some area of the solid concrete to avoid this contact zone between column and the slab? So there was a lot of investigations. You have this test set up. So we have this is like a column, and the slab made of bubbles of a different type. So we made a test. And you see there's a different failure characters depending on the solution you choose. So the main goal of these tests were to find out which is the optimal solution. Full of bubbles, a little bit more solid concrete, or cross type concrete. Okay, there's numerical investigations also we've done, and the numerical investigations then they're tested in the real scale in the lab. There is another solutions in case if you can't manage it with the bubbles by playing with a different pattern of them. We can use the additional reinforcing steel to reinforce this contact zone. There is another pictures. Also, the bubbles itself were investigated a lot. We tried to make different kinds of bubbles because the bubbles should have good enough support for the reinforcement. You know that the workers should walk on it, and they should not be damaged because of it.
We do construction like that, but it's made of bamboo, okay. And we have that problem you're saying, because when workers are walking on top, they just make it through, and they do a gigantic hole, and then when they're pouring the concrete goes in. That's a way that you never accounted.
So what they did, I think they did the special holding of the reinforcement, and which holds the bubble in place when you pour the concrete and vibrating. And it's also safe to walk on it. So they have these strengthening grips. So the bubble itself is the structural member. Okay, that's another test setup. See a lot of measurements of the cracking zone, the shear cracking, and so on. And for the sleepers, the ones which holds the railways, and it's a very expensive thing because it's a simple beam, pre-stressed slipper to hold the railway, but it's hundreds of thousands of them along the railway, and it's very costly to change them. You have to stop the railway, you have to remove the rails and put the new, make the ground. Well, enormous prices. So they said, the company, the railway company said that if you will make the research and if you can save the concrete and make them, they make the service life longer by 1 year or something, it's millions for us. So they paid quite a lot of money for the investigation. So you see, this is the half of the slipper. That's the railway supposed to be supported here. And we investigated the deterioration because of all the chemical products you can find in the railways. We have another problem in the Northern Europe. This is the freezing thawing cycles. You have a micro crack and it's okay, but then you have poor water in the crack, and the freezing, it expands. The water expands and freezing. And by this cycle, freezing and thawing, freezing, thawing, the cracks get bigger and bigger. You see, there is some testing. They tested what is the penetration of the water and the chemicals, and like this. That's the picture of this one. New. This is used 1 year, I guess. This one is used 3 years, so you see a lot of damage. For the anchorage zone, this reinforcement is pre-stressed, so losing of the anchorage is little. You are losing it completely. Okay, and that's the modeling. And as I said, we're doing the real scale test, but also sometimes we go to the microscopic scale. We analyze this contact between steel and concrete in details to see what kind of products are there. So now we know what caused the problem of losing the anchorage zone by analyzing the chemical composition. And for the non-metallic reinforcement, again, this is the in this case, this is basalt fiber reinforced polymer, but there could be many other carbon fibers, glass fibers, aramid fibers, well, all kinds of polymers you can find. And we try to make the tests with a pre-stressed non-metallic reinforcement. This is not very usual, but we found out that for the cyclic loads in the structures, this reinforcement is not performing very well. You should pre-stress it. But then you have another problem. So we have investigated that with different anchorage and different pre-stressing levels, how to make the. So that's the beam. This is the reinforcement. This is the anchors, and then you have to grab and pull it to pre-stress it before pouring the concrete. Then in testing the reinforcement itself, this basalt reinforcement looks like this. It's especially made a rough surface to get the better connection bond. So we try to be making the pull test, and we making the test pull out of concrete, and also the beams itself with this pre-stress reinforcement with a pre-stress of a different level. And we're testing lots of specimens, and we get different failure character, checking all the cracks. So that's my field. My PhD thesis was based on the flexural members, and I investigated these cracks. So maybe not so interesting. That's my job. And that's what the main result looks very obvious. Theoretically, it's clear, but what we did, we tested practically how it works, and we found out what is the value of pre-stress should be used to get most benefit of the structure.
And we lost it once
again. But I'm finished, so mostly there are, and you don't have to worry. I will send all of the slides to Professor Federico, so he can share with you. So because I move it very quickly, I have many slides, but I will share over all of it in a handout form, so you can read it later anytime you want. All right? So thanks for your attention.
Thank you guys for coming. Thanks a lot. I'll give this.
Thank you.
¿Quieres también una clase? Ahorita. Alguien, un profesor. para poder darle la presentación a él y que está espacio usted.
No, pues la verdad yo vine por Ingeniería Sin Fronteras.
Ah, chévere. Ah, bueno, entonces yo se la paso a Fabián. Fabián, que es el director del grupo, y que él se la saca y llegar a ustedes. Súper.
Bien, bien,
Muchas gracias.
Ustedes, muy interesante.
Sí, sí, sí. ¿Y sabes qué es lo mejor? Pues me vine a enterar que la movilidad está abierta con ellos. O sea, si tú te metes a la página de...
Sí, eso le estaba diciendo, que tendríamos experiencia nacionalización, a ver cómo es el convenio.
Exacto, y está abierto, entonces por eso es que él está aquí.
pero
Entonces,
algún promedio o algún
seguramente sí ahí deben haber algunas cosas.
Pues sí, pero, o sea, pero intercambio como para ir un semestre,
Sí,
una especialización,
sí.
o es doble titulación.
No, la doble titulación solo la tenemos con el Politécnico de Italia en Torino. Ese que ya está muy armado. Pero tú puedes irte un semestre a hacer asignaturas allá. Y como las asignaturas están en inglés, es súper fácil para nosotros recibir el sílabus de la asignatura y transformarle, ponerle checks a las asignaturas y fregado. Eso sí es muy fácil de hacer. They're interested in making a semester, professor.